Okay, this is lesson 5.4 on special parallelograms, part 2. Okay, this first example is about rectangles, and I have here rectangle FLAT. So I'm told it's a rectangle, and I'm also told angle 1 is 18 degrees. Well, the thing about a rectangle, because these diagonals are the same length as each other and they bisect each other, we have and then we've got, all the vertical angles congruent in the middle. We have, isosceles triangles. The rectangle is divided by the diagonals into 4 little isosceles triangles. So if angle 1 is 18, then this other base angle to this bottom isosceles triangle is also the same measure of 18. And angle 3, because I know that this whole thing, angle A, is a 90-degree angle, then angle 3 is going to be the 90-degree angle minus angle 2, minus 18, so 72 degrees. And then angle 4, angle 4 is going to be the same measure as angle 3, because that little angle, or that little triangle, let's make this this intersection point O, the triangle LOA is also isosceles, so angle 3 and angle 4 are the same measure, or 72 degrees. Okay, in the next example, let's say that we're told the diagonal length of FA is 27, and we're supposed to find the length of LO. Well, I can see that LO is the same as FO, which is half of FA, so LO, all the halves of those diagonals are the same, so this should be 27 halves, or 13 and a half. Okay, in the next one, if TO, so the diagonal going from here to here, that segment of the diagonal is 4x plus 7, and FA is 30, find x. Well, 30 should be twice TO, right? So I can write a little equation. 30 should be 2 times the length of, because each of those are half of a diagonal, should be half the length of TO. So 30 should be equal to 8x plus 14. So 16 is 8x. Oops. So x should be equal to 2. And x being equal to 2 would make TO equal to 4 times 2 plus 7, or 15, which is half of 30. Okay, this is an example that uses the theorem involving the midpoint of the hypotenuse of a right triangle, how it creates 3 segments that are equidistant from that midpoint, the midpoint is equidistant from all 3 vertices of the triangle. So anyway, in looking at this diagram, I'm told that it's a right triangle and M is a midpoint. So right off the bat, I know that this segment and this segment and this segment are congruent to each other. But for right now, I'm asked to find angle measures, so I'm told if angle 1 is equal to 32, what's the measure of angle 2? So this is what I'm always telling students is, look for those isosceles triangles. I have a triangle here, GMR, with these 2 sides congruent, this triangle on the left, meaning this base angle 1 is congruent to this base angle 2. So if angle 1 is 32, then angle 2 is also 32 degrees. Now angle 3, because angle G, the entire thing is a 90-degree angle, angle 3 is 90 degrees minus angle 2, so 90 minus 32, which is 58 degrees. And then if that's 58 degrees, angle 4, again, notice that triangle GMI, the triangle on the right, has these 2 congruent sides, so it's an isosceles triangle. And so I know that, let's do this in purple, this angle and this angle, angle 3 and 4, must be congruent. So if angle 3 is 58, then angle 4 is also 58 degrees. Okay, so for a second example, we're told if angle 4 is equal to 7x minus 3, and angle 3 is equal to 6x plus 1, find x. Well, as we just said in the last example, angle 3 and angle 4 are congruent to each other, so I just equate these 2 expressions. So 7x minus 3 must be the same value as if I distribute this 6x plus 6. So subtracting 6x from both sides leaves an x on the left, and adding 3 to both sides puts a 9 on the right. So x must be equal to 9. Then angle 4 is 7 times 9, or 63 minus 3, which would be 60 degrees. And angle 3 would be 6 times 9 plus 1, or 6 times 10, 60 degrees, and that would check. Okay, so in this last example, I'm told that GM is 2y plus 3, and RI is 12 minus 8x. So examining the figure, I know that this segment GM is the same length as RM, which is the same length as MI. So RI has to be 2 times the length of GM. So I can say RI is going to be equal to 2 times GM. So then writing my equation, RI, which is 12 minus 8x, is equal to 2 times 2x plus 3. I think I need to make this is an x. So let's see here. On the right-hand side, if I simplify through distributive property, I'll get 4x plus 6. So continuing on, if I subtract, or if I add 8x to both sides, I'll have a 12x on the right. And if I subtract 6 from both sides, I'll have a 6 on the left. So if 6 is equal to 12x, careful here, dividing both sides by 12, x is equal to 1/2. And that is it.